Hi, Algebra 2 students. I hope you had a good weekend and you're ready for another week of exciting math. All right, we're going to start our new unit on polynomials. We're just going to spend a couple weeks, actually 3 weeks, in this chapter before we move on to logarithms. So our first topic is dividing polynomials. Multiplying polynomials should be reviewed from Algebra 1. So here's just a quick review of the two methods that you maybe learned during Algebra 1. So on the left, we have the area model, okay? We can see that our two multipliers are outside of the area model, and then we fill in each box with the product of the two things that line up. So here we've got a times 2 is 2a. Down below, we have 2 times negative 3 is negative 6. And we fill in our area model in that way. We combine like terms, and then we write out our final answer. So you maybe learned to multiply that way. Another way you could have learned is just by distribution. So we distribute this a to the 2, negative 5a, and a squared in the next parentheses. Then we distribute the negative 3, again combine like terms, and here's your final answer. So notice both methods involve similar steps of multiplying individual terms, combining like terms, and then writing out a final answer that's the same. So our focus this week is dividing polynomials. We are going to learn how we can use an area model to divide, or we can use long division to divide. Either way will get to the same place, and you will be able to choose which method works best for you. And you can just do that one method. Then we're going to look at a shortcut called synthetic division that I will want you to be able to use in certain situations. So again, you're going to be able to choose area model or long division, but then I need everybody to know how to do synthetic division. So we're going to go through these. I'll probably have 3 videos loaded so we can split them up. All right, let's take a look at this first one of how can we use an area model to divide polynomials. So the way we set it up is we take our divisor, x plus 3, and we write it on the left-hand side. And I like to write the plus or minus sign next to my constant so that I remember if it's positive or negative. Okay, next we're going to take our dividend and we're slowly going to build it inside of our area model. So the first term is 2x cubed. So I'm going to write that in this first box. Now what I'm going to do is start building my quotient. So I need to ask myself, x times what is 2x cubed? The answer to that question is 2x squared. Now I have enough information to fill in this square below, right here, because I can see that this square needs to get filled in with the product of 3 times 2x squared. So that would be 6x squared. Now remember from before when we looked at the area model example for multiplying, the like terms were along the diagonal, and our like terms together showed up in our final answer. So when we're using the area model to divide, we need to acknowledge that there's going to be 2 like terms here, and together they need to be equal to whatever is in our dividend. And what I see in our dividend is 2x squared. So I have to figure out what would go in this box. What would I combine with 6x squared to make a 2x squared? And that would be a negative 4x squared. So think about it right now. If we were to combine these like terms, would they be equal to what we see above? Yes. Okay, we are now going to repeat this process until we are done. So now I'm back at the point where I'm going to be building my quotient. X times what is negative 4x squared? That would be a negative 4x. I now have enough information to go down below and multiply negative 4x times 3 is negative 12x. Whatever I put in that top box needs to be equal to a negative 4x. So what do I need to add on to negative 12 to turn it into a negative 4? It would be a positive 8x. Now that I have a term at the top, I go back and say x times what is 8x? It would be a positive 8. 8 times 3 is 24. Again, what do I have to add on to 24 to make 24? 0, nothing. That means my remainder is 0, and that 2x cubed plus 2x squared minus 4x plus 24 is divisible by x plus 3. We have a remainder of 0. So the answer to this problem is what we see on top of our area model. 2x squared minus 4x plus 8. The way we could check our answer is we could now go and we could try multiplying our answer by our divisor. And if we multiply those together, we should get the dividend that's at the beginning. Okay, we're going to try more together. And again, if we do some of these, a whole bunch of these together, and you're still feeling confused, don't worry. I've got another method you can use if you don't like this one. Okay, first thing we need to do is put our divisor on the outside. Next, we're going to start putting in our dividend for x cubed. And now I'll start building my quotient. X times what is 4x cubed? 4x squared. Go down below and multiply. 5 times 4x squared is 20x squared. Now we have to look back and look at our x squared term, 23x squared. What do I need to put in that box to add on to 20x squared to make 23x squared? Yep, 3x squared. Now we repeat. X times what is 3x squared? That would be 3x. And it's a positive, so I put a plus sign. Go down below and multiply. 5 times 3x is 15x. Look back up above. We need these two things that are diagonal to add up to 14x. 15x minus 1x is 14x. Now we go back up. X times what is negative 1x? Negative 1. 5 times negative 1 is negative 5. Oops, sorry, I was not consistent with my color coding. Negative 5. And now we look back up at our dividend. Our last term is negative 5. That means we would have a remainder of 0. So when we have a remainder of 0, our dividend is divisible by our divisor. Listen to all this vocabulary. Okay, so our final answer is what we see on top of the area model. The final answer is 4x squared plus 3x minus 1. All right, so like I said, you do not have to use an area model. I'm going to pause the video right here, and then you can come back to the second one to learn about long division, and then we'll have a third one on synthetic.